In this video, we are going to talk about periodic signals, both in continuous time and in discrete time. We have already discussed continuous time and discrete time signals in previous videos, and you can find the link above. As you can see in the figure, a periodic signal is a signal whose pattern or template repeats from -infinity to +infinity. If we look at the discrete time case and call this template xn, we can see that the signal keeps repeating. This is one period, then another period, and another one. And so on. Similarly, for continuous time signals, if we denote the template by xt, this pattern repeats from -infinity to +infinity as well. One of the most important concepts in periodic signals is determining the period. For discrete time signals, the period is denoted by n, and for continuous time signals, the period is denoted by t. To find the period, we simply measure the time distance between two identical points in consecutive repetitions. For example, if we count from one repetition to the next, and we move 3 steps, then the period is 3. It doesn't matter from which point we start counting. If we count again from another identical point, we still obtain the same value. The same idea applies to continuous time signals. The time difference between two identical repetitions is the period t. Now let's express periodic signals mathematically. If we consider the template in discrete time as xn, then the next repetition is xn minus n. The next one is xn minus 2n. And similarly, we can write xn plus n, xn plus 2n, and so on. The periodic signal is simply the sum of all these shifted versions of the template. In closed form, we can write a discrete time periodic signal as the summation from -infinity to +infinity of x and minus kn, where n is the period. Similarly, for continuous time signals, we can write the summation from -infinity to +infinity of x t minus kt, where T is the period. If you substitute specific integer values for k, such as plus or minus 1, plus or minus 2, you will obtain exactly the repeated pattern shown in the figure. Therefore, any periodic signal, whether continuous or discrete, can be represented using these summation expressions once the period is determined. In this video, we explain the concept of periodic signals in both continuous time and discrete time cases. If you found this topic interesting, you can check out our other videos on signal properties and solved problems in signal and systems.